Hello, everyone, and welcome to Fresh Concrete. This is the third of this year's Fresh Concrete events, produced in collaboration between the Concrete Centre and the Building Centre. My name's Elaine Toogood. I am Director of Architecture and Sustainable Design at the Concrete Centre, and I will be hosting today's event and introducing you in just a moment to our speakers. So this is an online series. It's been created to share just some of the wide-ranging innovative practices and new types of concrete that are emerging to address climate change. So these are all technologies that bring a fresh approach and fresh thinking to the way that we make and use concrete. So hence the title, Fresh Concrete. So the recordings from last year's series are all available online to view through these two links, as well as the events that we have run already this year in 2023. So if you haven't already, I urge you to take a look. There's some really interesting and thought-provoking innovation there, not only in the manufacture, but also in the use and the construction of concrete. And they include things like graphene-enhanced concrete, structures designed to be and reassembled, self-healing concrete, concrete that can help passively charge vehicles that drive over it, and of course 3D printed concrete. Also, new recipes for making concrete, some of them that capture carbon. So today's talk is on a similar theme to that, in that it features Carbonite and their development of an innovative, low-carbon, magnesium-based concrete, offering the potential to make concrete using a combination of magnesium silicate and agricultural byproducts, so as alternative materials in the manufacture of concrete. So I'm delighted to be welcoming Rajeev Sood, who is founder and MD of Carbonite, and also Professor Dr. Thomas Brook, who is co-founder of Carbonite as well, but he is also Werner Siem's Chair of the Synthetic Biotechnology at the Technical University of Munich in Germany. So while Thomas and Rajeev get themselves ready, I will just remind those of you tuning in that there will be time for questions at the end of the session. So as we're going along, please do put your questions in the Q&A box at the bottom of the screen, and I will endeavour to ask of many of those questions as possible as we're going along. Now, we may not get time to go through all of those. So the plan is that we will share the questions left over with Rajeev and Thomas afterwards, and they'll be able to respond to you directly. So please, if you don't want a follow-up answer, then ask your question anonymously, or do let us know when you ask the question that you don't want to follow up. So over to you now, Rajeev and Thomas. Thank you very much.
Hello, welcome to the webinar. Thank you very much for joining us today. So I'm Rajeev Sood. I'm going to talk a little bit about Carbonite, which is our environmentally friendly method for the production of a novel cement. So basically, next 5 years, we're looking to yield production, but we are looking in the next 3 years to actually scale up production with partners and industry professionals. Carbonite has a number, 10,000 products that have been trademarked. So we will be looking for some product endorsement. And we obviously have to meet all the industry standards and accreditations over the next 3 to 5 years, or immediately actually. So a little bit about us. Carbonite was formed in 2013 to help provide solutions to develop green technologies, really for the construction industry and the utility sector. So our goal has come about to the realization of a global objective for carbon neutral development. That's what we'd like to achieve. We'd like to associate with companies that are moving in this direction. This year, 2023, our primary focus is to get the final development of our product lines and the production of the cement, which is a free pour cement. But initially, we're going to go with product development before we offer the free pour. So there are multiple lines that we're looking at, and there will be licensing opportunities, but at this stage, we just want to get the products ready. Now, we all know about cement, so I don't need to say too much about that, but I would like to say that Carbonite does offer an opportunity that is cost effective. It does produce, it's 21% less, it's cheaper to make. It has a 65% less CO2 than Portland cement at the moment. That's the numbers that we can verify and show on data. It uses a bio waste, which is a form of lignin that is added to our formula, and it is obviously a carbon capture and storage vehicle. Potentially, this will be a carbon zero solution, and we can introduce it to existing plants that are already there. We just need to retrofit a few areas. Temperature-wise, I will run through what the temperature differences are, which can affect the burning of the product. If you look at this slide, you'll see on here, you can see the main, where it's heated, where limestone or Portland cement, as we all know, is heated to 1450 degrees, whereas carbonite, and the mineral here is olivine. That's the main use of it, which is burned at 700 degrees to activate, showing thermal savings of up to 53% in the manufacture of carbonite, as opposed to Portland cement. So we don't need to build a new factory. We can use existing factories, but we could have to make them a little bit slightly different. We have to tweak them a little bit with the joint relationships with the main cement manufacturers. We can come to some way of making that happen. Electric kilns would be ideal, and that's an area that we also would like to talk about. I believe there is research and development taking place in these areas. Olivine is the key ingredient that goes into carbonite. There are reserves. We have signed various contracts with various companies that guarantee us olivine reserves, and they, as you can see from this map, it shows where they are. So they are in abundance all over the world, and there is no shortage, as some people were suggesting in the early days when olivine was first mentioned. Right, so some of the properties of carbonite, I'd just like to quickly run through this. We don't need any acids to activate the ingredients, so there is a very clean tech. The bio waste that we use is a key ingredient, and we're offering clean tech solutions for this, because the waste is repurposed and we could use it within our mixes. I think 5% to 7% is what we utilize. Thomas will be able to help me with that shortly. 50%, we are calculating that 50% less energy is used just merely in the burning process. That means just on thermal energy alone, there's a 50% saving. As far as the ingredients are concerned, there are saving costs there as well. And we are saying, or we are giving analysis of 75 to 125 kgs of CO2 is captured per metric ton of carbonite production. We also have experimented with seawater, and that needs further development, but that is an area that we are also looking at for future R&D. As you can see, the zero emissions targets, everybody knows about those. I don't think I need to cover this too much. I think we're all aware of what we're trying to achieve. This will give you a little comparison on what is in carbonite compared to Portland cement. As you can see, 89% of our olivine is utilized and is working quite well, I think, as opposed to the Portland cement 74%. So if you look at these, temperature and surface area, there is another comparison chart which I'd like to show you. And this one covers various strength issues, temper issues, heat, density, and the technical stuff that everyone likes to know about. So we can cover that a bit later on if need be. Thomas, I think, will be able to help us with some of those. Yep. Basically, what we're saying here, the manufacture of the process, there are significant parts of existing Portland cement factory that we need to keep. So it's not like we'll need a brand new factory. We can utilize factories. So there's a cost saving quite high there. Right. The products that we are thinking of bringing to market at the moment are blocks, pavers, plaster. I'm not sure if we're going to go with plaster and render now. I think we might take that out. I think we're going to go with bricks and blocks and free pour cement. If you've heard the experience, the terminology of technology readiness level, we're at technology readiness level 5. 6, 7, 8, and 9 is where we need to achieve full-scale production and out there to marketplace. So that is where we're looking to go. At the moment, we're at technology readiness level 5. As you can see, the idea was started in 2003. We did the lab testing and applications for the European patents in 2007. Patent was granted in 2017, and by 2019, the team was formed for commercial exploitation. So 2023 to 2025, we're looking forward to full-scale production and alliance partners over the next coming years. The current team are, as here, there's myself, there is Thomas Brook, Frank Bonham, who's our scientific support, and Thomas Neggles, Department of Chemistry and Innovations Material at TM University. All of these people are eminent in their field, and I look forward to working with them for the rest of the year. So I'm going to hand this back over to Lane. Thank you very much for listening. I hope I was able to cover some of the pieces that you needed to hear about. Thank you very much.
Thanks very much, Rajeev. That's a great introduction to your project, for your products. So delighted to welcome Thomas Brook as well on the call. Hi, Thomas, calling from France, I think you are. Yes. And you'll be able to provide some of a little bit more of the technical information about the product, I believe. So I'm going to start asking a few questions, and hopefully we'll get some. We've already started to get a few Q&A through. I urge everybody to ask the questions that they have. So olivine is the main basis of this material, which I believe is a magnesium silicate. Is that right? And the principal process of that is that this raw material is ground and then heated to release its cementitious properties. Is there anything else that needs to be added? Anything else you want to say about that?
No, actually, your activation energy is much lower. So you're at between 650 and 700 degrees. You emit water in the process, not CO2, because it's a hydroxide-based mineral. And that certainly has advantages from the carbon footprint itself. Moreover, we are using biogenic waste materials to modulate the physical properties, the binding time, and also the viscosity of the material. And all of those are waste streams from either the food industry or the biofuels industry. So the lignin that Raj touched about is actually coming from a second generation bioethanol process that is implemented on commercial scale. But there's several other waste streams that we can utilize, and it's very much dependent on the local infrastructure that we encounter with our partners.
Excellent. Oh, no, but that's helped answer the next question I was going to ask you, was what that biomass product brings to the system. But what you're saying is that still an area of development? So what you're saying is that potentially there could be, once you identify the core requirements of that biomass, then there might be different streams that can provide you with that to suit the sort of the waste stream availability in different regions globally. Exactly.
And you have to look at supply chains and availabilities of these biomass resources. But we have done this extensively, and with our partners, we're actually going forward. There are ready mixtures already available for some of the core systems that we supply. So we are ready to actually meet all the industry standards, particularly for the breeze blocks and so forth, where very clear performance guidelines are given. And we have developed that together with our colleague Tom Nilgis, who's an inorganic chemist and also a specialist in the building industry who knows all these standards off by heart.
Excellent, thank you. So in terms of we've got quite a few questions that are coming through about the potential use of this form of cement in concrete. So for example, one of the questions with any, for example, high levels of GGBS or secondary cementitious materials is early strength gain and its potential for use with post-tension slabs, for example. I think we saw a slide flashed up quickly there about early strength gain. Is that something that you've looked into and tested at any great degree?
Yeah, of course. Early strength gain is something that is dependent on admixture as well. So our system is freely miscible with any classical Portland cement. And there are actually synergies when you go for early strength development and you use both systems. But the Carbonite itself has a significant early strength gain as well.
Okay, so what was that? Sorry, Rajeev, do you want to
Yeah, the strength gains match. We've done testing on it, so they do match the gains that are industry standards. So we have done some testing. We have got some some data that we can show if need be.
Excellent, thank you. So I think you answered two questions in one again, Thomas. Is so brilliant, preempting what I was going to say. So we've got so there's the one question which Rajeev just talked about, which is the Carbonite product being used as the cement. But are you saying that and that as it's so far it's shown excellent early strength gain, but are you also saying that potentially this product could be used as a secondary cementitious material?
Absolutely.
I think you may have done, yeah. So do you want to say a little bit about that?
So certainly we have run several tests with free admixtures of classical Portland and other cementitious materials, because you also know that there's clay-based cements. All of those are admissible with our product, and there are synergistic effects between both products, yeah, in terms of cost as well as CO2 match. So if you still are in an application where strength and cost is in line with Portland cement, then our product will help you to become more carbon negative, yeah, without a loss of performance or cost increase.
We can utilize the Portland cement as well as our Carbonite mixtures to give that enhanced that they require for the industry.
Excellent. So so we've established it can be used as a sort of a blended, or however at what point you do the combinations, or standalone. So there's some more questions that have come up with regards to the potential cost comparisons for now. I think the comparisons you gave were against cement. There's some specific questions here being asked about concrete. So I suppose that's to do with the amount of cement that might be necessary to be used. So is it similar quantities of cement going into the concrete?
We can do cost analysis on 50% or 25 or 70%. Over to you, Thomas. But we have done those mixtures. The cost-wise will just be a direct representation of how much is in the blend.
Yeah, so you put some figures on the screen previously, which people could go back to and have a look at the cost. I think that was by comparison to Portland cement. So is it a similar amount going into the concrete? Are you looking at sort of, yeah. Okay, yeah. So that's a direct comparison. You can scale that up to concrete then. And what about for its use? So other performance questions, the two parts of the questions, Hasi, was about geotechnical questions, geotechnical structures. So that's to do with its exposure class within the ground. What has there been many tests with regards to that in terms of its performance and longevity?
So certainly longevity, so aging tests have been carried out, and they're comparable to what industry standards are like. Where Rajeev has touched on is the marine application, which becomes more and more important in ensuring sort of climate change dependent changes in sea level and the protective measures that we have to do for our coastlines. So here we are still in testing at the moment, but it's where we see a significant rise in application for these products.
Excellent. So many of the questions are about testing, as you would expect, because that is always the key challenge, isn't it, with regards to anything new that's coming through. So we have a question about fire. Have you managed to get to that far, or is that a sort of next stage testing?
That's certainly next stage testing. We have not gone into the testing for fire safety. There's different regulations in the UK and the EU.
Of course.
So as you imagine, the team is both in Germany as well as in the UK. We have to look at both regulatory frameworks. And for that, we need to find partners as well that are capable of doing that.
Yeah, but as on a fundamental level, you wouldn't anticipate there being a particular issue, because there's nothing that actually burns that's in the
it's already burned.
Yeah, it's already been heated, but it's a mineral base. The issue with regards to what amount of cover and fire protection it will be able to provide for any embedded steel, for example. And also its spalling potential in terms of water content. So that again, next stage development, as you say. Has there been any? What about from a sort of the durability and the long-term visual aspect of it? So efflorescence sometimes can be regarded if there's any free limes within obviously there isn't lime, but is there any changing in the performance that's been noticed? And actually, do you want to talk about the color, because that is quite significant as well, isn't it?
It is brownish. It's there's a sort of beige color to the product. Yeah. That has to do with the side minerals that are occurring in olivine, but you can tweak this depending on the olivine grade. Yeah, but the technical olivines that we've been using, the beige color is something that we experienced on a long-term level. There's no change in that coloration. And fluorescence, we haven't experienced. Sometimes it is wanted, yeah, for the appearance of the product. What we have tried is to embed fluorescent material, yeah, in the product.
So efflorescence, sorry, right, okay.
Yeah, so that, for example, you have a pavement that glows in the dark, yeah, all of that is possible.
I think we've got a language barrier.
Yeah, I mean, fluorescence is
Thomas, efflorescence. So that's a specific area where the in lime-based materials, free limes come on, and it looks like a sort of salt line that appears.
No,
so you get it on bricks sometimes. Yeah,
no, we don't have any of that. We got fluorescent bricks though.
Very exciting that you're embedding those in there. Yeah, absolutely. Everything's possible with forms of concrete, isn't it? No, brilliant. Thank you. Sorry, that was I wasn't speaking clearly enough there. Okay, fantastic. So there is a question which I was anticipating, which is what is the main difference between your technology and Ceratec? Ceratec have featured in some of our Concrete Futures events, and within the UK is becoming well known as an olivine-based technology. Are you able to answer that? It does require, or do you not know enough about Ceratec?
I don't know enough about Ceratec, but maybe Raj does.
Yeah, I wouldn't like to comment at this stage about, I don't know enough about Ceratec. I do know that they have mentioned olivine in their formulas. I do think that they're not burning olivine, whereas we are. So there are some differences. And plus we're a manufacturer from zero to product. I don't know exactly where they are. So I wouldn't like to say to make a comment, if that's all right. Yeah.
No. Sorry, I was on mute. That's fair enough. Making a comparison with somebody else's innovation is slightly challenging, but I was expecting that question to come through, because we are now starting to hear quite a lot about olivine as a material source, and the fact that it has, as a magnesium silicate, it has cementitious properties. So people will naturally be looking at the two together, which is very interesting.
If I may just say one thing about the olivine, there are significant supplies available. And we do know that it is an abundant source, but there are different grades of olivine that we can utilize in our product lines. So we have been in talks with suppliers. They are happy to supply us, and we do have written emails and delivery times and things like that. So there is no issue with the supply of olivine in its raw form, 3 microns. But just thought I'd let everyone know, because I know that there was discussion about olivine. Olivine's been talked around for a long time, since 1977 actually, so even before that. So here we go. So I just wanted to say that there are supplies. Thank you.
No, that's excellent. Thank you very much. So I'm just going through this. We've got a lot of questions here. So I'm trying to find something that's slightly different. I guess what somebody wants to know, how far have you got? What's the largest amount of concrete that you've managed to make so far? I mean, what in terms of the stage? I mean, it's lab based still, aren't we?
Yeah, I mean, sorry.
Is demonstration scale. We talk about half a ton.
Half a ton.
Yeah.
And we've also have been in talks with people looking to do a test site on a number of sites in the UK. So there is talks going on about where our first area will be, so we can actually have a real, foothold on the UK market or have a look at the UK market to see where they can touch it, feel it, and see it. You know.
Thank you. There is an interesting question here, which is about the combination of Portland cement-based concrete and olivine, and whether as a product, I guess as a mortar, might it ever be able to be used to repair concrete structures? Can you see any challenges with that, Thomas?
To be honest, this is something to be tested, because the repair of current structures is very specific. Yeah, we have to distinguish between micro cracks and macro cracks, where you have steel fouling or, you know, larger pieces of the building being fallen off. Yeah, and it requires different kinds of cement. Yeah, and as you may know, there's also other activities going on to have living cement activation, where you use bacteria or fungi to actually heal microcracks. That's certainly not the area where we see Carbonite as a product. It would rather be the macro repairs.
Excellent, thank you. Yes, I thought it was quite a niche question, but it is an interesting area to consider, isn't it, with regards to if there's going to be moving away from a material that we've been using a lot of recently, and then the combination of the two. So listen, there was very many questions here. We are not going to have time to go through them all, I'm afraid, but thank you very much to everybody who's asked them. I think the last question is related to product EPDs, which I'm sure you haven't gone through, but it does, well, unless you tell me different, but it does raise a question about sort of verified data, and this has all been done through do you want to talk a little bit about the papers and the support information that you have around your product? I think that's certainly something people would be interested in.
Raj, you want to talk to this, or should I?
No, you go ahead, Thomas.
Yeah, so we have verified the data using our university equipment, and together with the chair of building chemistry and Tom Nilger's chair for innovative materials. So we've gone through the standard testing materials, which are also verifiable. They're all normed. There's a norm test, and from that perspective, we are actually quite sure of the data that we have. Yeah. The next stage would certainly be scale up, and in scale up, you need to go through the rigorous regulatory testing at large scale. Yeah, and that's still outstanding. That's TRL 6 to 8.
Yeah, absolutely. That's the next stage, which we're very excited for you in terms of hoping you manage to get onto that stage and working through. So thank you very much today. That's been really enlightening to understand a bit more about Carbonite. And I'm going to just, and thank you very much, both of you, for coming along. And it's great to see this international collaboration to resolve this. So I'm now just going to share my screen to introduce the very last session of which is that our next and very last event of this year's Fresh Concrete series is going to take place on Wednesday, the 26th of July at 1 o'clock again. And that session is called Growing Concrete. Thomas just mentioned there the use of bacteria to fix cracks. Well, BioXeroc have developed something to grow concrete from scratch. So Liv Anderson, founder and CEO of BioXeroc, will be joining us in about a month's time to provide some more information, and you will be able to book for that through the link here on both the website of the Concrete Centre and the Building Centre. So thanks again to our speakers today. Thank to you for attending, and hopefully see you at our final event in July. Thank you very much.